Science has not only changed the way we look at the world but had a huge impact on society. It can be sometimes elusive to see how a given research is affecting us or going to affect us in the future. To put things in the right perspective, consider this. When Newton laid down the fundamental laws of calculus and laid down the foundation of theory of gravitation in 1600, it was a bit obscure at the time that we will use the same principles to actually land probes on Mars or land man on the moon. According to Carl Sagan, in an effort to raise public awareness, it is imperative to bring the fruits of our research to the public at large. To give you another example, consider the cell phone technology that we had in the 90s and compare them with what we have today, and you will see that scientific research has played quite a bit of role, and this holds true for pretty much every field, whether that be medicine, whether that be computation, whether that be aerospace industry. My field is electromagnetism. Electromagnetism is one of the fundamental forces of nature. This is a very well-established field. The study of electromagnetism led to the discovery of a cosmic microwave background radiation, which is actually the reminiscent of the Big Bang. And this discovery is somewhat of a cornerstone in understanding the fundamental reality of our universe. To give you another example, light in itself is an electromagnetic wave. It's actually a very thin slice of the larger electromagnetic spectrum. The focus of my research is antenna design. Any communication system, like for instance a cell phone, an aircraft, and Hubble telescope, will need an antenna to be able to communicate. So different antennas are actually designed for different application. To give you some perspective on this, you might have seen big antennas on top of buildings. So I have a scaled down version of those antennas. This is called a dipole antenna. This is a simple possible antenna that actually radiates in this plane every direction, and actually we feed this antenna from this side. So here we actually feed our antenna, and this actually radiates in all directions. This is somewhat of an omnidirectional antenna. As we would like to have more coverage, we would like this antenna to radiate in this direction. So for that particular application, this antenna might be required. Another antenna that you might have seen is actually this one. It's called a patch antenna. As you could see, it's relatively low profile compared to what we have previously. It radiates in this plane, and it's actually much more what you could say portable. So this is the antenna type of an antenna that we might have in a cell phone or in a laptop. So this can be carried on a person. So assume that we would like to have another kind of antenna that would radiate a large amount of power in a given direction. So to be able to actually achieve that, there are different sorts of antennas available. So I'm just going to give you an example here. Consider this. This is a simple horn antenna. Now you could see that it's actually not quite low profile. This antenna has the property of actually radiating a large amount of power in this direction. So as you could see, the application domain and the application requirement dictates what choice of antenna should be made. As we have seen, different applications require different antennas. The focus of my research is on one specific kind of antenna called a leaky wave antenna. To understand the basic principle of a leaky wave antenna, let us consider the following analogy. Consider that we have a water pipe, but this water pipe has some holes in it. Now we put a specific volume of water through one end of this pipe. So as we can see, as the water propagates through the pipe, it leaks. And due to this leakage, the volume of the water at this end is going to be larger compared to the volume of the water at this end because of the leakage factor. Now in the last analogy, we replaced the water pipe with an electromagnetic structure, and the water with an electromagnetic wave. So, as we have seen, as the water propagated through the pipe, it leaked. Similarly here, as the electromagnetic wave propagates along the structure, it leaks into the space. And this is where the radiation comes from. Now, this was the fundamental principle of how a leaky wave antenna radiates. There are different aspects of radiation. For instance, the angle at which the antenna is going to radiate, or the frequency at which the antenna is going to operate, or the polarization of the radiated beam. So now there is a concept called reconfigurability. Now, to understand that, let me give you another example. Assume that we have a knob and we tune this knob such that the leaky wave antenna radiates in a given direction. We are presume that to be phi 1. We are going to presume that to be phi 1. Now what we do is actually further tune this knob such that it radiates in another direction while not physically moving the antenna. So this is just like an analogical way to understand what I mean when I use the term reconfigurability. It could hold true for any antenna radiation parameter. It could be a frequency shift. Assume that the antenna is radiating at one frequency band, and we tune the knob and it actually goes to operate in another frequency band without actually physically moving the antenna. This kind of antenna is much welcomed in satellite and space application because it has the potential to reduce the cost in terms of initial investment and maintenance. And that's why we are actually working on this antenna. And another huge motivation behind this project is to be able to understand a little bit better the phenomena of leaky wave and build up a theory which will not only help us design better antennas but also help us in the future. That's a concise summary of my project. I hope you liked it. Thank you very much for your time.